Okay, this lesson, 10-6, is going to be our introduction to circles and arcs and arc length and circumference and area. So all sorts of just sort of generic, basic things about circles. So let's talk about some vocabulary. In a plane, a circle is the set. Circle. So the circle is the set of all points equidistant from a given point called the center. You name a circle by its center. So we're going to name this circle P. So circle P. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. So PC is a radius. So let's define radius. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. So PC is a radius. So this is PC, and it's a radius. Notice when I named it, I always start at the center. So when naming segments in a circle, we always start at the center. If it's a half, like a radius, if it's starting at the circle and going to the outside edge, we start with the center to name it. For example, the next sentence, PA and PB are also radii. So the word radii just means more than one radius. And we're going to go ahead and label these, PA and PB. Okay, all three of those are considered to be radii. Congruent circles have congruent radii. Congruent circles have congruent radii. A diameter is a segment that contains the center of a circle and has both endpoints on the circle. So a diameter goes through the center, from one side through the center to the other. That would be segment AB. And so notice when we name that segment, because it goes all the way across, we start with the name where it starts on one side of the circle, and then we tell where it ends on the other side, B. So A is where it starts, and it goes to B. And we know it's a diameter if it goes through the center. Okay? A central angle is an angle whose vertex is in the center of the circle. So remember, we have this angle, and this is the vertex point. So if that vertex point is the center, then that's considered a central angle. Okay, angle CPA is a central angle, this one. Central angle because the vertex is at the center of the circle. Okay, so those are just some terms about a circle. So when we say radii and we say diameter, I will repeat the definitions of them, but that just gives you a little bit of an idea. All right, the next thing we need to talk about are the arcs of a circle. So arcs. Okay. So an arc, I want you to think about like the piece of the pie, okay? So an arc is part of a circle, and it's measured in degrees, and the arc is like the outside edging of the circle. So an arc, think about a piece of pie, and I want you to think about just the crust. So just the crust of the pie. So if this is my piece of pie, right, and I've got my nice fluffy crust, that's the part I'm talking about. Just the outer edge. It kind of looks more like a piece of pizza, but you get the idea. Just the crust, okay, not the inner section. An arc is a part of a circle, and it's measured in degrees. Okay, so when we're talking about arcs, we're talking about the outside edging. Okay, so the arc, a major arc is greater than a semicircle or more than 180 degrees. We're going to define these with the pictures in a second. Greater than semicircle, and that means more than half the circle, so more than 180 degrees. Okay? A minor arc is less than a semicircle, and that means that it is less than 180 degrees. Okay? A semicircle is half of the circle. And so that equals 180 degrees. Okay, I think most of you kind of figured that part out already. Major is greater than 180, minor is less than 180, and a semicircle is half. An adjacent arc of the same circle sharing one point. Adjacent arc. These are arcs just like adjacent angles that are next to each other. Okay, so arcs next to each other. Whoops. Next to and there's some things about them. They share a side. Just like our adjacent angles did that, right? They shared the side. They were next door neighbors to each other. The same thing happens with the arc on a circle. They're the two pieces that are next to each other, and they share that common wall in between them. They share that one point. So here are three examples. So in the first example, we're going to do this. T, circle P, and then S, and then I'm going to put R over here. Okay? And we're going to say in this one, T, R, S. And I'm going to draw this symbol over the top. That means arc. T, R, S is semicircle. Okay? TRS is a semicircle. That means that arc TRS is 180 degrees. And so just to reiterate or give that some clarity, you start at T because the name is TRS, you travel to R, and then you travel to S. So there is our arc. Okay, semicircle, TRS. Okay, second example. Looks almost the same. We're going to do T, P, and S again. And this time when we do R up here, we're going to actually connect the radii to the center of the circle. And this time we're going to say that RS, arc RS, is a minor arc. Okay, that means that arc RS is less than 180 degrees. And so here is arc RS. Starts at R and goes to S. So that's arc RS. It's less than 180 degrees, so it's considered a minor arc. Okay? The last example, T, P, S. Again, R goes up here, and this time RTS equals a major arc. And so that means that RTS has to be greater than 180 degrees if it's a major arc. So RTS, you have to follow the letters in order, right? So they said R, T, and S. So from T we go to S, RTS. So if we go in that direction, from R to T to S, we end up with more than half the circle. That's a major arc. Okay? So let's flip the page. Let's go to the next page. And I'm going to ask you to just pause the video for a moment. And, well, first we'll label it. And then I'm going to ask you to try those questions. See how you do on them. Oh, it's already labeled for you. Sorry. So I want you to look at those practice questions. Name the minor arcs, the major arcs, name a set of adjacent arcs, and name a semicircle. So you can pause the video for a moment, give those ones a try, and then go ahead and play the video to get the answers. Alright, so the minor arcs, I'm looking for arcs that are less than 180 degrees. And so I hope you said arc AD is less than 180 and arc CD is less than 180. Now you could have said arc DA, which is exactly the same thing as arc AD, or you could have said arc DC. Again, CD and DC, they are exactly the same arc. It doesn't necessarily matter which direction you go to name it. Okay? Major arc has to be greater than 180 degrees. So an arc that is larger than 180 degrees, okay? So you could have said arc DAC. So starting here at D, going around to A, going around to C. So that whole section greater than 180. You could have also said, so we started here at D, you could have started here at A and said ACD, okay? ACD. So first we said DAC, we sort of left out this chunk, but the next time we're going to go this way, ACD, and we're going to leave out this chunk. So you could have also had ACD. Again, you can do that in reverse order, CAD or DCA, same thing. Okay, name a set of adjacent angles, so two angles next to each other. So I'm looking for sure at angle AD and DC. They're next door neighbors, AD and DC. We could also say that we have DC as a next door neighbor to CA. It doesn't matter the size, they just have to be next to each other, so that works. And the third set you could have had was CA being next door neighbors to AD. Okay, so there's three next door neighbor sets there, three adjacent arcs. And then the last is naming a semicircle, so exactly a half of a circle. Now, when you name a half of a circle, it's usually important for us that you name it with 3. So we would say A, D, C. So that takes care of sort of what we would call the right-hand side, ADC, this side right here. If you wanted to name the other side of the circle, there are only 2 points, and so it would be satisfactory in this problem to also say AC. We'd like to try to use the 3 if there is a point there. If there isn't, well, then we just use the 2 that are there. Okay? So that's naming some arcs. Okay, let's move on to circumference. So we're going to take and go ahead, slide the page. Circumference. Okay, so the circumference of a circle is the distance around the outside edge of the circle. So that whole distance around the crust, if you laid a string around the outside edge of your pie or outside edge of your pizza, you can then straighten it out and measure it. That would be the circumference. So the distance around the circle. Okay, distance around the circle. So that's circumference. And the definition or the formula for circumference is circumference equals 2 times pi times r, r being the radius of the circle. So the distance from the center to the outside edge. 2 times pi times r. Circumference equals 2 times pi times r. Okay? So concentric circles and their properties. This is a picture of two concentric circles. That means that they have exactly the same center, but one is larger in diameter than the other, so they overlap each other. So there's a little circle, and directly on top of it, on top of a larger circle. So here are some properties. They are in the same plane with the same center. Okay, so in the same plane with the same center. That means they overlap. Okay? Another property about them is that radius AB is less than radius AC. Okay, radius AB is less than AC. So that makes sense. From A to B is a shorter distance than it is from A all the way out to C. And the circumference of circle A is less than the circumference of circle B. Okay. So the circumference of the small circle is less than the circumference of the larger circle. Seems pretty self-explanatory, right? The distance around the outside edge of this circle, the smaller circle, is going to be shorter than the distance around the outside edge of the outer circle. Okay? So that is circumference in a nutshell. Arc length. Arc length is a fraction or a part of a circle's circumference. Okay, part of a circle's circumference. Think about the crust of the pie. I just want a piece, a part of that. Okay, so this length of this segment from one spot to the next, if I were to lay a string flat from one piece to the other, what would the distance of that part be? Okay, so we call this AB. Okay, so I'm going to scroll the page up just a little bit and make some room. Okay, let me clear the screen, get this stuff out of the way, and move this up so there's just a little bit more room. I guess it doesn't go up anymore. Alright, so I guess I'm at the bottom of the page. So let's go back here, AB, and I'm looking for this is the arc length, okay, the length of that segment. Now, the formula for the arc length is this. It is the angle measure, however many degrees it is, out of 360 times the actual circumference, 2 times pi times r. So when you're multiplying this together, you are taking a fractional piece. This is the fraction part. How much out of those 360 degrees do you have? Okay? So if this is a angle that is x degrees, I need x out of 360 degrees of the circle's circumference. Okay? So I'm taking a fractional piece of the circle's circumference. Think about if I said I want 1/2 of a amount x, 1/2 of x, right? So when we write it this way, 1/2 times x, we read it 1/2 of x, right? So it's a fractional part of the circumference. So it's this fractional part of the circle's circumference. So you multiply them together. So I want you to be careful when you're doing this. We're going to have angle measure over 360 times 2 times pi times r. So when you get ready to multiply that out on your calculator, here's what I always tell students to do. Start here with the r, multiply by pi, multiply by 2, multiply by whatever your degree measure is, and then divide by 360. And that way you won't make a mistake. Instead of dealing with taking this, dividing by 360, getting some fractional piece, and then this, and then this, and then this, it's nice to just kind of start on this side, do all your multiplication, and then divide. So you're just going to multiply across the top and then divide by 360. Okay? So multiply across the top and then divide by 360.